All right, Dr. Williams. Today I'll be solving chapter 18, problem number 52. So the first one we need to do is find the equivalent resistance between point A and point B. The first thing I realize here is that these two resistors here are in series, which means that they can just be added up. So we're just gonna add this 1 ohm resistor here. We're gonna come and we're gonna add that 3 for the 2 and the 1 added together. And we're gonna drop down our 3.3 ohm here. Now I see that these two resistors are connected in parallel. So I know that 1/4 plus 1/8 equals 1/Req. which would just translate to 1/1/4 plus 1/1/8, would give us a total answer of 2.67 ohms. So now we're gonna drop down our 2.67 ohms. Connect these back up. So now we see that these two are now in series, so they can just be added up. Redraw again, 1 ohm, 3 ohm, and this would be 5.97 ohms. Now again, these two are now in parallel, so we're gonna do the same, 1/5.97 plus 1/3 will give us a resistance of 1.99 for these two, for this parallel circuit. Now we're gonna drop it down one last final time. 1 ohm, 1.99 ohm, which will give us a total equivalent resistance, 2.99 ohms for this series. For this circuit, I'm sorry. Now for part B, we need to see if an 18 volt EMF was connected to point A to point B, what is the current through this 1 ohm resistor here? Well, I know that the total current in will equal the total current out, and at this point, no current has been lost. So I know that I total will be the current through that 1 ohm resistor, which is V total over Req. It gave us V total, which was 18 volts, and Req we found to be 2.99 ohms. So I'm going to solve that to give us 6.02 amps, which is the total current in the system, which is also current through R1 for part B. Now finally, we need to find the current through this 8 ohm resistor here. And we're gonna do that by trying to find the current through this whole bottom branch. To do that, we need to find the voltage drop after this first ohm resistor to tell us the voltage coming into this parallel circuit here. To do that, we're gonna multiply our I total times R1 to see the volt drop after R1. So that's going to be our 6.02 amps times 1 ohm, give us 6.02 volts dropped. So we're going to subtract 18 volts minus our 6.02 volt drop, and that is going to leave us with 11.98 volts entering in this parallel system here. So I'm going to go ahead and redraw very quickly, very rough drawing. This is our 4 ohm, and this is our 8 ohm. This is 3.3. We found the equivalent resistance of this bottom branch. We're going to call this B. We found the equivalent resistance of this bottom branch to be 5.97 ohms. So now we can go ahead and divide our 11.98 volts entering that bottom branch divided by our 5.97 ohms, which will give us the current flowing through that bottom branch, which is 2.18 amps. So that's going to be ITB for the bottom branch. So now, using the current dividing rule, we can solve for the current in this 8 ohm resistor. And we're going to do that by doing 4 ohm over 8 plus 4 ohms times IT, which is just 2.01. So it's going to be 4 over 12 times 2.01. And this will give us the current in that in this 8 ohm resistor, which will leave you with 0.6699, which we're just going to round to 0.67 amps. So for part A, we got a total equivalent resistance of 2.99 ohms. For part B, we found the current the current in 1 ohm to be 6.02 amps. And for part C, we found that there is 0.67 amps in the 8 ohm resistor. So I hope that answered all the questions. Let me know if I need anything else.